Good day to everyone. Today I'll be talking about a paper entitled Quantifying the Provisioning and Regulating Ecosystem Services of the Pagsanjan-Lumban Watershed, Philippines. Now, before I start talking about the study itself, let me give you a brief introduction on the topic. As we all know, land conversion and other human activities has and continues to degrade ecosystem services, not only in the Philippines, but around the world. Now, according to Sutton et al., he estimates that over 6.3 trillion US dollars of ecosystem service values is being lost annually due to diminished ecosystem function and due to other similar drivers in ecosystem degradation. And this is especially true for the Philippines because Philippines is a country that's experiencing rapid growth and development, both of which result to rapid urbanization. And this is exacerbated by the lack of effective management, which lead to the further deterioration of our watersheds and the deterioration of ecosystem service supply. In fact, in 2013, the National Economic Development Authority had identified deforestation and the lack of effective management of forest and freshwater ecosystems to have led to the further deterioration of our watersheds and further limiting their ability to recharge our aquifers and increase water runoff and eventually increasing soil erosion rates. Hence, the study aims to tackle this problem by measuring the contribution of various land cover classes to the total ecosystem services of a particular watershed. Now, when we're talking about ecosystem services in the study, we're referring to two different types of ecosystem services. First is the provisioning ecosystem service, which is estimated through the water yield. And we also have a regulating ecosystem services, which is the sediment retention. Now, for the location of our study site is the Pagsanjan-Lumban Watershed, which is located in Region 4A and covers two provinces in the region, particularly the Quezon Province and Laguna. And this watershed encompasses 7 major municipalities, all in all covering around 45,000 hectares. Now, what's interesting about this watershed is majority agricultural. So it's a very agricultural watershed. Aside from that, this watershed is also the largest contributor of water and sediment to the Laguna de Bay. Laguna de Bay is the 3rd largest freshwater lake in Southeast Asia, and it's part of the Laguna de Bay River Basin, which is also a part of the larger Manila Bay River Basin. Now, understanding the relationship between ecosystem services and the types of land cover that's present in the Pagsanjan-Lumban Watershed is important because this would give us an idea on how these interrelationships happen, because this would give us a better understanding of the similar, because this would give us a deeper understanding on the interrelationship between the land cover and the ecosystem services in the larger river basins which the Pagsanjan-Lumban Watershed comprises. Now, the Pagsanjan-Lumban Watershed, aside from being a very agricultural area, is also experiencing a very high growth in population. In fact, this region is the 2nd most dense region in the Philippines, only second to the National Capital Region, which is mostly made up of cities. Now, due to its proximity to NCR or to Metro Manila, this region is experiencing rapid urbanization and thereby increasing the rate of land conversion in the area. Now, if left unchecked, this process could degrade the supply of ecosystem services in the landscape, and hence, this is why we're doing the study. Now, in order to understand and in order to quantify these ecosystem services, we use the integrated valuation of ecosystem services and trade-offs, or INVEST software package. The INVEST software package is a suite of free open source software models used to map and value the goods and services that we derive from these ecosystems. Now, what's good about the INVEST models is that these models are spatially explicit, meaning it uses spatial data as input, but it also creates spatial data as its output. And this is very important because we're not just quantifying the ecosystem services in terms of absolute values, but this spatial analysis would enable us to understand and show the distribution of different ecosystem services across the landscape or across the watershed. Now, for our study, we use two models from the INVEST software package. The sediment delivery ratio model was used for estimating or quantifying the sediment retention in the area, while the annual water yield model was used to estimate water yield. Let's look at the first model that we use in the study, the annual water yield model. The annual water yield model is a simplified version or representation of the hydrologic cycle. The only problem with this is that it's based on annual averages, which means that our estimates are limited to annualized averages of water yield. And because we're relying on these annualized averages, we tend to neglect extremes in the climatic conditions, which could affect the distribution of water yield throughout the year. And this does not also consider the temporal dimensions of water supply, due to it also not considering sub-annual patterns of water yield. Another limitation of this is that it does not really do that well representing how complex land use patterns could eventually impact the water balance in the watershed. So if you want to incorporate those types of information, then the annual water yield model may not be for your study. You may want to use the seasonal water yield of the INVEST software suite. Now, this model uses the Budico. Now, this model uses the Budico curve in order to estimate water yield. Now, the Budico curve is shown here in this formula, but instead of using actual evapotranspiration, it uses these different parameters in order to estimate water yield for all pixels in a particular watershed. Now, the characteristic of this Budico curve water yield estimation is that water yield using this particular methodology is defined as the combination of overland flow, interflow, and base flow. And this particular model could not discern the contribution of all of these three different components to the total water yield. So it just describes the total water yield without really breaking it down to its components. Now, for the next model, the sediment delivery ratio model, we use this to estimate sediment retention in the watershed. The only problem with this is that it is limited to modeling, or it can only represent rill or inter-rill erosion processes. Now, for the result of the study shows, or the preliminary results show, that the watershed and its ecosystems provide approximately 528 million cubic meters of water per year. This water is, of course, surface water. And looking at the contribution of each land cover, The traditional perennial crops contributed around 44% of the total water yield, while brushlands and traditional annual crops comprise 20% and 40% respectively. Now, in terms of sediment retention, the Pagsanjan-Lumban Watershed retains around 34.8 teragrams per year of sediment, which is equivalent to 34.8 million tons of sediment per year. And around half of this is retained by traditional perennial crops, and 27% is retained by closed forests, followed by brushlands at 9%, followed by traditional annual crops at 6%. However, it's important to note that these totals are heavily influenced by the areas occupied by each land cover class. Hence, it means that if you have a land cover which encompasses a larger portion of the watershed, it is more likely to influence the total sediment or the total ecosystem services provided by that particular land cover. Hence, we did another analysis for unit area comparison. Now, using the unit area comparison, we see that the mean water yield potential of the land cover classes had ranged from 690 millimeters per year to around 2,000 millimeters per year, with modern perennial crops yielding the lowest values and the built-up areas contributing the most to water yield in the area. On the flip side, the mean sediment retention potential for each land cover ranged from 14 tons per hectare per year to around 6,254 tons per hectare per year. And the highest contributor to sediment retention was closed forest, amounting to almost 600 tons per hectare, followed by open forest, and then traditional perennial crops. While the lowest contributory value to the mean sediment retention was the modern annual crops. So all in all, we could say that the study had quantified the ecosystem services in the Pagsanjan-Lumban watershed particularly well. And in the study, we had looked at both sediment retention and water yield. And in both models, the results had supported the idea that different land cover types would provide varying levels of ecosystem services. So one type of land cover will have a different set of ecosystem services to another type of land cover. So one may have a larger ecosystem service for water yield, or another may have a larger set of ecosystem service for sediment retention. And the study has also showed that knowing the benefits of knowing the estimated ecosystem service benefits of appropriate interventions or of our agricultural production systems would actually help promote the sustainable practice of agriculture, because once we pair the estimated or the quantified ecosystem services with the agricultural production system, then we can start to begin to look at the concept. We could start to look at the concept of estimating trade-offs. So once you want to change the land cover of a particular parcel of land from one land cover to another, then you need to take into account that one land cover may support different sets of ecosystem services, and you may want to prioritize the land cover which you want to retain in a particular parcel of land. And lastly, the maps generated of this study, the maps generated from the study could actually help identify hotspots and cold spots in the ecosystem services in the Pagsanjan-Lumban watershed. And this distribution of ecosystem services could actually help address authorities or decision makers, landscape planners, and watershed planners in order to assess the possible ecosystem services trade-offs for land development in the Pagsanjan-Lumban watershed. So that's the results of the study, albeit just preliminary results. And thank you so much for listening.